Okay, this video is going to show page 30, numbers 1 through 4, and what you need to do to complete this. Remember, try to complete this on your own. Use this video as a guide to help you to complete it and or to check your answers. So the first one is talking about packs of hot dogs and hot dog buns. And you want to see what is the least number of packs of hot dogs you can buy when you want to have the same number of hot dogs and buns. So for this one, you're going to be looking for the least common multiple because you're having a combination of these things, you're multiplying them together. So for this one, I would list the multiples of 6, and then I would also list the multiples of 8. And you're going to be looking for the least common multiple of those two numbers. So I would go 6 times 1. Now, of course, you can do this mental math, but if you want to make certain you're getting the least common multiple, you can also do it this way. So 6 times 1, 6 times 2, 8 times 1, 8 times 2. So far, no common multiples yet. And then 8 times 3 is 24. And once again, my number is quite a bit bigger here. So I'm going to go back up to the 6 and do some more of the 6s. So I was at 6 times 2, now 6 times 3, and then 6 times 4. So now we have our least common multiple, which would be 24. That's all you need to do there, just list out the multiples of each number. So if you had, for this one, you should know how many packs then of each as well. So if the hot dogs buns come in packs of 6, that means you'd have 4 packs, 4 packs of the buns. And then for the hot dogs, you would have 3 packs. So if you were going to the store, you'd buy 3 packs of hot dogs, 4 packs of hot dog buns, then you'd have the same number of each, 24. 24 hot dogs, 24 buns. Next one here, number 2. So this one, you're going to be dividing these to make identical packages. So if you're dividing these out or sorting them out, for this one, you're going to want to use greatest common factor. So you can go back to what we learned about the factor trees and prime factorization. That's one way to do it. Or you can list different ways to get the number 36. So either way would be fine. So I would most likely do it this way. The factor tree can take a little bit longer and can possibly confuse you, but you want to look at the different combinations of the way to multiply to get 36. So like I know 1 times 36, of course, is a possibility. I know 9 times 4. And I know 6 times 6. So I'm not going to list 6 twice. I'll just leave it there as 1. Then I'll move on to the 45 erasers. So I know, of course, 1 times 45. I know there's 5 times 9. And I know there's 3 times 15. So you need to think about all the different multiples that will get you 45. So then you're looking for the greatest common factor. So I see a 1 on top and bottom. I see that's it, except the 9. So the only other common factor is 9, and that's the greatest common factor. So this would be 9. So they can have 9 packages. And now another way that you can look at this also is what would you multiply that 9 times to get 36? So for the 36 pencils, you'd have 9 bags, right, or 9 packages. And then inside each bag, since 9 times 4 is 36, in each bag, there would be 4 pencils. And then you could do the same thing for the erasers. There's 9 bags, and you know 9 times 5 is 45. So inside each bag, there would be 4 pencils, and then there'd be 5 erasers. Then for number 3, 46 graders and 24 seventh graders, and you are dividing them into teams. So now there's different ways that you can do this, and this is also a thinking problem as well about making groups or teams if you're doing some type of activity. So let's once again list these factors of 24 and 40. So of course I can do 1 times 24. I could do 1 times 40 as well. I could do 8 times 3. I could do 4 times 10. I can do 6 times 4. I can do 20 times 2. And then I can look for these greatest common factors or all the common factors. So, for example, 1 is a common factor. So I could separate them into one team, right? 24 in one group and 40 in the other. But I'd want to look for a greater number. So I see here the number 4, right? And this might work well because if I put them into 4 groups, I'd have a good number of groups for that class or those groups of students because I'd have 4 times 6. It'd be 24 for the number of 7th graders, right? I'd have 4 groups of 6. And if I had the 4 for the 6th graders, I'd have groups of 10. So if I combine them into one group, right, I'd have 6 of the 7th graders and I'd have 10 of the 7th graders. That might work well. So there's other possibilities you can do. And then last one here, number 4. So this one says every time she babysits, she saves $12 of her earnings. Every time Aaron babysits, he saves $9 of his earnings. After babysitting a number of times, Sarah and Aaron have the exact same amount of earnings. What is the least possible amount of savings they could each have? So you're looking for when they would match each other. So for this one, you would list the multiples of 9 and multiples of 12. So after one day, 9. After one day, 12. You want to see when they would be able to meet one another. So 9 times 2, 18. 12 times 2, 24. 9 times 3 is 27. 12 times 3 is 36. 9 times 4 is 36. So this is when they would meet one another. And then this person, since it's 9 per each time, they would have had to work 4 times. 9 times 4 is 36. And then this person, since they made $12 each time, they'd only have to have worked 3 times. Then they would match up each other. That would be the answer to number 4.